All right, so now that we're thinking about these probabilities in terms of x represents the number of something and then the probability of that, we can calculate the mean because we have numerical values everywhere. So the mean of a discrete random variable is found by taking the sum of the x values times their probabilities, and that gives you the mean. So remember, this guy stands for mean, sum. These are our x values and their probabilities. We don't have to do any division. We're just looking at the multiplication piece. So let's look at an example. James has an ice cream cart. He finds the probability of selling X number of vanilla cones in a day, and the results are in the probability distribution below. So here, X represents the number of vanilla cones that James sold. So he sold 120, 130, 140, 150, 160, 170, 180, or 190. And then the probability of each of those outcomes. Now these probabilities were found using the relative frequency or empirical method of calculating probability. So James had to actually look at how many cones he sold per day out of the possible number of cones that he could have sold. How many of them were vanilla versus how many of them were chocolate or whatever. So this was not a calculation for probability that was found by counting things like we do when we're rolling a die. Just so that's clear. So now we want to find the mean number of vanilla cones that James sells. So what is the average number of vanilla cones that James will sell? So to do that, I'm going to take each x value. So the first x value is 120. And then I'm going to multiply that by its probability. So the probability that James sells 120 cones is 0.071. And that is 8.52. Then I'm going to do the same thing for the next one. So 130 times 0.071. That is 9.23. 140 times its probability, which is 0.143. That is 20.02. 150 times its probability, 21.45. 160 times its probability, $34.4. 170 times its probability, 12.07. 180 times its probability, 25.74. And then finally, I'm going to take 190 times its probability, and that is 27.17. So now I have multiplied each possible x value by its probability. So now I want to add all of these results together. So 8.52 plus 9.23 plus 20.02 plus all the way down to 27.17. So when I do that, let me actually do that to be sure that I get the correct answer, because it's very possible that I made a mistake. We get 158.6, and that is in fact the correct answer. Now it's okay that this is a decimal because this is an average. The average number of cones that James sells, I'm sorry, we're specifically looking at the average number of vanilla cones that James sells in a day. Is 158.6. So that is the actual calculation of the mean with a probability distribution where you have x values and the probability of each of those x values. So then another term for the mean of a random variable like this one is the expected value. Expected value is notated as e of x. Now the calculation for expected value is completely the same. It's just another term for the mean. Mean and expected value are the same thing. The only thing that changes a tiny bit is the interpretation. So instead of saying that the average number of cones that James sells in a day is 158.6, we would say that James can expect to sell 158.6 vanilla cones in a day. On average. There really should be an on average in there somewhere because it is still an average. Okay. So for James, this would be useful because if he knows that he can expect to sell 158.6, he may not want to bring less than that, but he may not want to bring a lot more than that either. He wants to make sure that he has enough vanilla ice cream in his ice cream truck to get to 158.6 or 158.9 since we are talking about cones. So he can use this expectation of how many he's going to sell as kind of a good starting point on how much vanilla ice cream he should have in his ice cream truck. Another way that expected value is useful is in problems like this next one. So this next example says, in order to raise money, a charity decides to raffle off some prizes. The charity sells 2,000 raffle tickets for $5 each. The prizes are 10 movie packages worth $25 each, 5 dinners for two worth $50 each, 2 smartphones worth $200 each, 1 TV worth $1,500. What is the expected gain or loss if you buy one single raffle ticket? So you decide you're going to take part in this raffle, but you can only afford to buy one raffle ticket. So we're going to look at how much could you expect to gain or lose if you participate in this raffle based on the amount that the raffle ticket costs versus how much the prizes are worth. So what I'm going to do is I'm going to start by underlining what's important. So they're selling 2,000 raffle tickets for $5 each. There are 10 movie packages worth $25 each, 5 dinners for 2 worth $50 each, 2 smartphones worth $200 each, and 1 TV worth $1,500. So now I'm going to set up a probability distribution table, but I'm going to have an extra column at the start. So I'm going to have a column for what I win. Okay, what I win or my outcome. Then we're going to have X, which we'll talk about what that represents in a second, and then the probability of X. So I'm going to actually set this up with 3 different columns. So the first column here, I'm looking at what I win. So if I participate in this raffle, I could win a movie package. So I'm going to list that as one of my possibilities for winning is the movie package. I could also win the dinner for 2. Or I could win the smartphone. I could win a TV. Or I could win nothing, which would be sad. So I'm going to put a little smiley face next to him. So now, what I win is the movie package. The X value for the movie package is going to be the worth. How much this prize is worth. So the prize is worth. So the movie package, each prize is worth $25. Each individual dinner package is worth $50. Each smartphone is worth $200, pretty old smartphones. Each TV is worth $1,500, pretty expensive TVs. And if you win nothing, your prize is worth $0. So now in this case, when we're looking at what the prize is worth, or when we're looking at what we want to assign for our X value, we're going to assign the dollar amount for the prize that I've won. Now I need to figure out the probabilities. So the probability that I win one of the movie packages. So I know that there are 10 movie packages out of 2,000 raffle tickets. So 10 people are going to win movie packages, or rather 10 raffle tickets are going to win the movie package. And they're selling 2,000 of these tickets. So this is 10 winners with 2,000 possibilities. So that is 0.005. Now the dinner prize. There are 5 dinner prize winners out of 2,000 total possibilities. So 0.0025. There are 2 iPhone winners out of the 2,000 possibilities. 0.001. And there is 1 TV winner out of the 2,000 tickets. So this is 0.0005. Now I need to figure out what is the probability that I win nothing. Recall that the distribution for a discrete probability distribution, the probabilities must sum to 1. Right now, we do not have a sum of 1. We have a sum of 0.005 plus 0.0025 plus 0.001. We have a sum of 0.009. These 4 probabilities equal 0.009. So if I use the complement rule, I can find that the probability that I win nothing is 0.991. So now if I sum this PX column, it sums to 1. Because it has to in order for it to be a valid probability distribution. So now I have a distribution with X values and probabilities for each of those X values. So I can go ahead and figure out the expected value, which means I'm going to calculate the mean. So I'm going to go ahead and do this. I'm going to do it more in one step than I did the last one. So I'm going to take the X, 25, times its probability, plus the next X value, times its probability, plus the next X value, times its probability, plus the next X times its probability, and then finally we have the last X value times its probability. This is going to give us the mean of this distribution. So go ahead and calculate that real quick. And I got 1.2. I'm just going to double check all of my decimals real quick. Yep, so I have a mean of 1.2. So the average amount of prizes, or the average worth for the possible prizes, is $1.20. However, this is not yet our expected value. And the reason for that is because we purchased our raffle ticket for $5. So we actually paid money before we got to participate in this raffle. So we have to take that into consideration. So then the expected value, E of X, the expected value of these prizes, is the average 1.2 minus the cost. So people who participate in this raffle can expect to lose an average of $3.80. So I'll write that down. So the people participating in this raffle can expect to lose an average of $3.80. They are losing money because the expected value is negative. If the expected value is positive, that would mean that the people are on average gaining money in this raffle. And that's a good raffle for you if you're the one participating, because that means the average player is coming away with money. With this one, the average person is losing money in this raffle. So here is a little bit more complex of a problem on how we can use the expected value to figure out the worth or the value of some sort of raffle, or you can use this for carnival events and life insurance policies, and all sorts of problems can be solved using the expected value.